We're going to talk about some very general properties of some general classes of materials by playing a game called Will It Float? First of all, we have metal here, we have a piece of aluminum cable here, and as you can see, it's very typical of many metals in that it's very easily bent into different shapes, and it tends to hold its position once it's bent out of shape. In terms of its density, well, we can check to see if it is more dense or less dense in water. If it's more dense in water, it will sink in water. If it's less dense in water, it will float. And we put this in water and we can see that it indeed sinks. Most metals, all metals I can think of, are more dense than water. Okay, so here I have a piece of brick from a building they took down at Bradley not too long ago. It's an example of a ceramic. Bricks tend to be very hard, and well, like most ceramics, very hard. Might even be able to break off pieces of the brick, but it's not very flexible at all. And in terms of density, will it sink or will it float? It sinks. Okay, obviously pretty dense compared to water. Okay, and here we have a piece of plastic soda can holder. It's made out of plastic. It's a polymer, and it's pretty flexible. Notice it doesn't stay bent out of shape. It's also not brittle. Now again, there are brittle polymers. All of these materials can have a variety in their properties, but I'm talking typical properties. And we find that most polymers, or many polymers at the very least, tend to float. Okay. Many polymers are less dense than water. Not all, but many of them. And this brings up the idea that in terms of if you hear about trash in ocean gyres and stuff like that, like the Great Pacific Garbage Patch, what does the trash tend to be comprised? Is it metal? Is it ceramic? Or is it plastic? And we find that it tends to be comprised of plastic materials. Because they often tend to be less dense in water, and they tend to float.